Well, thanks everyone for showing up to Understanding Asset Dependencies in Unreal Engine 5, Hard Refs and you. So today we are covering what asset dependencies are, why they exist, when you don't want to have them, what you can do to try to avoid them, and when they're okay to use and you should be using them. It's not something to be scared about, it's just something you should be cautious about. And then if you're down the road, you're about to release and everything hits the fan, how do you fix those problems? What are the tools available and resources for you to actually systemically try to make that better? And I have some links to some additional great resources and talks, and then we'll have some Q&A, and then later, if you're interested, we're going to go over to 10 Barrel Brewing for some food and drinks. What is an asset dependency? Well, it's when another asset references another asset. An asset is anything in the engine, a material, a blueprint, a data table, or a widget, which is kind of like a blueprint, but with the UI and stuff like that. It's those things that you see in the content browser in Unreal. And many times, those things will reference other things, whether that's in variables and things like that. We'll go ahead what makes a hard reference. But references can be hard and or soft. That means hard references, they load immediately. When you load asset A and it references asset B, it has to load asset B before it loads asset A. It's this way of you're telling the engine, look, like I can't do anything unless this thing is loaded into memory. And so that's what a hard reference is. A soft reference is, I have this reference, but the class, this asset can function without it loaded into memory, and we'll load that sometime during runtime, whenever that may be. An asset dependency chain just means, I'll use that term a couple of times, it's when it's the whole chain of dependencies that you make when asset A refers to B and B refers to C. Anything that refers to B will also load C when it's a hard reference. And so you get this really dangerous exponentiation issue where if asset A refers to 10 different assets, and then each of those refers to 10 different assets, and then some of them circle back and then they come back, now you have this like real nightmare of a problem. I call those asset dependency chains, and you try to keep those as small as possible to prevent issues. Some examples of hard references are variable types. That is either you're making a blueprint, in the details panel you have local variables for functions or the variables for the blueprint. Inputs and outputs to functions, all of those, the types of that variable, and I'll have some pictures, I think, a little bit later, those will make hard references. If you say the type is of this blueprint actor, my character, now you have a hard reference to my character. Anytime you cast to a thing, even if you don't use the result of the cast, that still is a hard reference. Any input pins to functions that you specify which class you want to do, like spawn actor, those are hard references. Components, so skeletal meshes, the materials that you say that you want to use for the skeletal meshes, anything that are in the components of like a blueprint, and then inheritance. So child classes that have a hard reference to the parent classes. We have to load the parent class for the child class to work. So why is this important? A lot of times you can just completely ignore this and ship a game, no problems. Usually it's because your game is a little bit on the smaller scale. You have less assets, maybe less complexity, and it's not a really big problem. You don't have a game that has a gigabyte worth of textures and all these other things, so long loading times don't really affect you because you could load the whole game and it still not be an issue. But generally speaking, if you load one thing, let's say the splash screen, and it refers to the game mode that has a reference to your controller, and then that starts this whole chain, loading your splash screen could load the entire game into RAM just by clicking on the exe or launch app on Steam. So we try to minimize our loading times for the specific assets to prevent these kinds of issues. Later down the road, if you're doing updates and things like that, and you're focused on like optimizing your chunk size for when you package, you can't separate packages across different chunks. They all go into the same chunk because that whole chunk's got to get loaded because it has all the dependencies. So you're going to end up with larger chunks with larger asset dependency chains. Seemingly innocent references end up loading half the game. We already talked about that. Symptoms will creep up slowly. You will not notice this is a problem until it is, well, not really too late. You can fix it, but man, it's going to be a lot of work. And there's a talk that I reference multiple times from Mark Craig from Lucid Games, and I'm not quite there yet, but eventually we'll be there. But pretty much every gray on his head is caused by a hard reference in an asset somewhere, and it is one of those things where either you're the person asking to have hard references fixed or you're the person fixing them. I tend to be the one fixing them. So here's an example from a game that I work on, and you can see here this is the UI player. It is the interface, the HUD of the player, and you can see here by loading it, it loads 4,900 assets. It's like, it's probably not the entire game, but it is pretty close. And that means that you're loading almost, well, it says at least 657 megabytes because I had to like make the window bigger and scroll in to like find more assets. So I don't know if it really got the whole size there, but it's very similar. Like, and the problems with this specific game, it's a couple of key references that are really hard for us to remove because we're later in production. We don't want to change a bunch of things because it's going to break things, or we don't have the time to do it because we're like strapped on cash. So ultimately, it gets to this point where all these things end up referring to this one problem child, and then that just does this huge circular dependency with the entire game. Same game, release day at 8 p.m. Fu told me, this is, yeah, like, I've been able to package this entire time and getting this weird error that says, could not clear async delete root directory. We have no idea what that means, but all of a sudden couldn't package. And another person, Bar, was like, what got it to work last time? I just deleted my save folder and it seemed to work. And that's when we were like, well, maybe it's the order and the references are being loaded. Remind you, Fu has been packaging this game for years and never having an issue. And then all of a sudden, when it was already late, we had these issues. Bar called me in to call in the cavalry, and then many hours later, oh, this was an interesting one. We found out that if you opened up Unreal and they loaded a specific asset before loading anything else in the editor by opening it up, the editor would crash, specifically due to a very, very long circular dependency, like multiple circular dependencies. Like I went around and then I went around and then I did it so many times that I couldn't defer that circular dependency because Unreal does handle it. It'll say, it's circular, I'll handle that later when I get a chance. It wouldn't get a chance with this one specific asset and it would crash the engine. So we basically just deferred it until asset X. We said, just don't open asset Y because that's less of a problem, and we were able to package and ship the game. Not a problem, right? So this is really important that when you are time crunched and all these things, I guess it depends on the scale of your project, but it is good to understand why these are problems and how to prevent them. So there are many ways, and this is probably not all of them, but the ones that I am more familiar with for avoiding dependencies that you don't need. Casting to a higher ancestor class, creating the logic of, we'll go over each of these in detail. Creating a logic only parent class, so that could be in Blueprint or C++. Don't put asset loads in the C++ constructor, the class default object. That's really for C++ people. Use soft class references when you can, and use Blueprint interfaces, but don't do it incorrectly. Very, very important. We'll go over that. Using proxy actors for multiplayer and messaging bus for events. So casting to the highest ancestor class. Let's say you've implemented Be My Character. This is your character that You're loaded into the game. It's got your skeletal mesh and your animation blueprint and a bunch of materials that have really high textures and all these other things defined in the defaults for that character. Well, if you need to do things like jump and move the pawn, don't cast to be my character when you need to cast. Cast to a character. Only cast to the things that are needed. In this specific example, I'm using this jump function, which is, you can see here that it says target is character. That's telling you the class that that function is belong to. So if I'm saying, okay, I'm casting it to do this jump, and then I'm like, oh wait, I could cast higher up in the ancestor chain. Let me do that, and then do the bottom here, where you cast to character instead. And now you just prevented that hard reference to be my character that's loading all of these textures, all of these other things. You probably have references to some widget and some other thing. Maybe you have a reference to a level, or you don't want to load a whole other level just because you want to load the character. That's one. It's an easy thing to do. It's just about being more patient when you prototype your code and try to only do the stuff that's necessary. Create a logic-only blueprint class that's used for casting. So similar here where we had be my character, we went to higher up. Sometimes there isn't a higher up. So you need to create a higher up. And this can be in C++ or Blueprint. A lot of people out there say, oh, you got to create C++ classes for every Blueprint class. And that's because of this main thing, is they put all the logic in the C++ class, which is very hard to load other assets in, and so you usually don't. But you could do it in Blueprint, where you have a blueprint that only has functions, it only has logic, it doesn't have any textures or anything like that. You can define the components or the default variables, and then you create a child class of that class, where you actually say, it's this skeletal mesh, it's this material, it's these things in the defaults panel. You can then change those things. So now you can cast to be my character instead of be my character child, where it's all defined. All those visual assets go in the child class. You still can have asset dependency chains. Don't get me wrong. This can still have them. But now instead of loading 500 megabytes, you're loading maybe 100 megabytes. So here I have this example. Everyone can see that all right? Cool. So we have be my character here, and it inherits from the parent class character. I got a couple of events here where on begin play, we're going to loop. On tick, apparently, we're going to jump. And this is just going to keep happening. And I want to be able to tell it to stop jumping. And I call this end jumping. There is a stop jump function, but for the purpose of this demo, we created our own, where we stop that timer so it won't call this event anymore. So you can see here in my character, I didn't define anything in my skeletal mesh or my anim class for the animation blueprint. It's completely empty. And then I right-clicked on the be my character in the content browser, and I said create child class. You could also say right-click blueprint, and then in the drop-down you could type in be my character to find it. But right-click create child class is the easy way to do it. And in this child class, it doesn't have any logic. All the logic is in my character, but I define the skeletal mesh and the anim class, and I created hard references to those in be my character child, whose parent is be my character. But now I can cast to be my character instead of be my character child. Wow, tongue twister. So I have in this other, I just put it in the game state for no reason, but it's there. We can say get player pawn, and now I can cast that to be my character, and I can call the end jumping function. So this becomes a very tedious thing to do, because now for everything you want, now you're going to have at least 2 of them, and now you have an organizational nightmare and things, and I don't know what the best practices are. I think that's going to be what works for you and your team, but generally speaking, for some of these things that are going to have a lot of textures, a lot of other kinds of references and things like that, try to create that. Like if you're going to create a shop, a merchant in an RPG game, and it's got 10 different meshes because you kit bashed it and you created it into a child actor, and each of those meshes have all these high, 4K textures. Maybe try to go to like a 1K texture or less, but if they had all 4K textures because it's really high def, now you could create a child, the logic only for doing the shop, which is interacting with it, purchasing goods and things like that, and then you have the child class that actually says, I want these actors to be, or those meshes to be part of the shop. Any questions there before we move on? Oh, and another thing is to double check if this worked out. You can close the child class and then reopen it, and it will say, hey, if you've ever seen this, it doesn't show like the event graph. It says this is a data-only blueprint because it realized that it hasn't defined any functions or any logic in it. And you're like, oh, okay, good. We only defined like the skeletal mesh and things like that. There's no logic in here. That's kind of what I was going for. So if you're a C++ user, there's a function for you to override what the class default object is. And in blueprints, this happens just in the nature of them. You have all these variables, and they all have default values for them. Well, if you're trying to, I'll try not to explain it. We can talk more about it later. But the TLDR is if C++ classes, they all load when the engine starts up, when the editor starts up, when the game starts up, because it's just kind of like, I got all these C++ modules, and those are super lightweight. The code is so lightweight, and it loads up. But the engine itself will say, hey, let's go call this class default object because I kind of need to know what's up. And it will, if you have a load this asset into memory in there, now you're loading that asset when the engine just starts up. Before you load a level or a game mode or any other of those things, just starting things up will load all of the stuff in the CDOs for C++. Not a great practice, probably, in general, but that's kind of one thing to keep out for. So using soft class references. So we got all these hard references, but can we use soft class references? And we can for things like spawning an actor or checking whether or not an actor is a class. So for spawning an actor, I couldn't find okay. So you might be able to see that the soft class reference is like a pink, and then a hard reference for a class is purple. It's a very slight change. But when you call spawn actor, it's a drop down, and usually would select it, unless you had it in a variable, but usually you would just drop down, type it in, and say, yeah, that's the class I want to be able to spawn. Well, what you can do instead is you can say async load class asset or load class asset blocking. The top one will be asynchronous, it'll load it, and whenever it comes around, it'll go ahead and spawn it. It's a great one to use, but in some cases, you need to block the actual execution path, and this can be problematic if it's a lot to load. You could cause some hangs in your game, but if it's nice and small, or if you know it's already loaded into RAM, because by the time you got to this level, well, sure as loaded 30 minutes ago. So if it's already loaded into RAM, this will be immediate. It'll just say, yep, I already got it, here you go. Otherwise, it will fetch it from disk and load it into RAM. And then from there, you can take, this is just going to be like an object class, so you have to cast it to an actor class to be able to put it in here. But and then I right-click and say, change cast to pure cast, so then I didn't have an extra line, but it'll error if it's not an actor class. But yeah, so that's how you use a nice little drop down. You could also put the soft class reference as a variable type in your blueprint, because you're like, oh, this is something I'm going to use in several different functions, and I want to just put it in one place, and you could do that too, and then you could still drag it here there's another node for loading a class, and it's called resolve soft reference, and it looks like this. It's not very definitive. It doesn't tell you anything other than it goes from pink to purple. But when you put it in the right-click menu, it's called resolve soft reference. But before we get to there, another common practice is casting to figure out, is this actor of this type of class? Because I want to do something if it's I know it's a weapon, but what if it's a melee weapon? Then I'm going to apply different type of damage than I would if it was a ranged weapon. Well, don't cast to weapon melee, because now you just created a hard reference. We don't really need to, where you could put, make this is not a built-in function. You would have to make this function, put it in like a little function library, and is actor of class, and you can provide the actor object and a soft class reference that you can select in this little drop-down menu to weapon melee. And what it will do is it will say, hey, resolve the soft reference. That's going to load it into memory, and then check to see if those classes are equal. And now we just totally didn't need that hard reference for just checking class type. Very useful, especially if you got like a lot of different types of logic, like kind of like in the weapon. You have all these types of weapons, and each of those weapons are going to trigger off different types of logic. You could also have like a different way of doing it is to have an enum in your master weapon class that says what type of weapon it is, and then in your child classes you say, oh, this is a ranged weapon, this is a melee weapon, and things like that, and then you can check off of that. Yeah?
Could you create like a template, or would that create a hard reference in the template, but it has to reference the other part of the...
What do you mean by a template?
Like just like, hey, here's the thing that I need you to check if it's this thing.
It will, if you do the cast to that, yes, it will create a hard reference to the template. But if your template doesn't hard reference other things, that's okay. You just created an asset dependency chain of one. That's okay. It's not a problem. And we'll get to this. Hard references are okay as long as what's behind it is under control. So that's totally fine if in your specific game that doesn't have a bunch of a big asset dependency chain behind it. So to repeat the question, I believe you're asking, well, let me try to rephrase to see if I can answer your question at the same time. The async load doesn't mean it's loaded. It might be loaded, but it may not. Let's say we had like 4 of these async load class assets in the same blueprint, and one of them got triggered already, and it loaded it into RAM. Later, down the road, 5 minutes later, a different thing, maybe the same event got triggered because you wanted to say, shoot rocket. And the first time it loaded it in, but the second time we're going to go to async load, give me the rocket. And it's already loaded into RAM because we didn't get rid of it, and doesn't load it again. That's correct.
Keep going back to it because it's a module.
That's correct. In both cases, these functions would return, in this case, the completed for the async, and then the other output pin. Those would happen just immediately. Be like, I already got it. Here you go. And that could be loaded somewhere else from another class, too. It's not just in that one class. It's kind of a global, did this class at all get loaded? Yes. Does that answer your question?
Yeah.
Cool. Any other questions about soft class references? Cool. This thing should be put in the engine. I got this specifically from Mark Craig's talk. It was a great talk. You should check it out. It's going to be a little bit repetitive, but there's some nuggets of good information in there, and there'll be a link at the end of the presentation. Okay, so that was soft class objects. And if you ever go into specifying the type of a variable, you'll see you have 2 different soft references. You have the soft class, which we just talked about, and they have soft object reference. And so my first thought was like, okay, well maybe like it's kind of like a soft class. We won't load the class, and it's just like a pointer in like a C++ term of this random thing and eventually we'll load it and it will be a soft reference. That is not true. Soft and the internet, there are a couple of like first 5 results on Google, they tell you that a soft object reference is a soft reference. It is not. It is a hard reference. It will still load it into memory. What they are specifically for, and Epic did a talk about it and was kind of confusing, and you had to like decipher the video, but here is what a soft object reference is for. It's the values of that soft object reference. Whatever you set that soft object reference for, those values are not loaded into memory immediately on the asset being loaded. And you still have to manually load that value. So it's a little unintuitive, but here's, in the Epic talk they had like a skeletal mesh, but I think what's even better is textures and materials. So let's, before I guess we talk about for this, not going to look at the slide. So what the soft object reference is really useful for is, let's say you have a building that is in a war zone, but the battle hasn't come yet. So you have this texture loaded of all of the pristineness of that building, but then later in the game, some bomb blows up or something, and you've got all this dirt, the texture totally changes, and that's a big 4K or multiple 4K textures of this building and the rubble around that. You don't want to have all that loaded into RAM beforehand, because you're just doubling your loaded space for no reason. That's only for the second half of the game. Why would you want that? So soft object references allow you to specify what those textures are going to be for that one actor, but they're not loaded until you tell them to load. And so it's a great one for like textures and materials. You load those in when an event happens, and you say, set the material now to these things that I have loaded. Otherwise, you would say you'd have 2 materials, one for pre-explosion and one post-explosion. And if you did just a soft object reference, or not, a normal object reference, they're both teal. The darker teal one, which is like kind of the default, you would make a hard reference to both materials, and both materials would get loaded immediately. Whereas a soft object means you can defer it. So I would almost like...
And that means, and really what would trigger it getting loaded is when a chain of actual...
There is a set of blueprint nodes for you to... It's always going to stay a soft object reference at the type. You just say, it's very similar to these functions, is you say load it into RAM and it returns a object reference for you to then use. You can say set material from there. So cleared up the air about soft object references. Probably less useful. The misnomer is very confusing. I don't really use them very often, but I could see with more high fidelity games or experiences that have lots of 4 and 8K textures, it can be very important for you to only load the ones that actually matter. It could happen with skeletal meshes too. Let's say you have the same character and you have this like backpack that has like a robotic arm that's coming out. Well, that has all these extra skeletal meshes and things, but you only get it when you get the power up or something like that. You only want to load that later in the game. Okay, interfaces is like the clear, this is this thing that people have been saying to use to avoid this, but people use it wrong all the time. Blueprint interfaces are great for avoiding hard references. They allow you to call functions inside of any actor that implements that interface, and if they don't, it's ignored, so it's pretty cool. You can check to see if some actor implements interface by saying, does implement interface, but that interface, which looks like this, you have a list of functions, and those functions have inputs and outputs. That's it. That's what a blueprint interface is. You're defining the things that you can call to this thing, and then the specific actors themselves will implement those interfaces, actually put the logic in them. Now, the problem is with using blueprint interfaces incorrectly is don't put hard references that you don't want in those blueprint interfaces, because now you're like, oh, I'm doing all this great stuff, I'm avoiding all these hard references, and you're just like, oh, go get the actor reference, and then you return a type B actor, and you're like, oh, I didn't cast or anything like that, but it's very easy to do that. Now you have an interface to that, and every single place in your project that you say, call this interface of any type, it doesn't even have to be this function. You could have like 30 functions in this, and you could call a function that only returns a Boolean. It will load the entire interface, and you have a hard reference to that other actor in this other function. So it's if you do this all over the place, and then you say, okay, I've got a couple of interfaces that are like core to my game, because from an organization perspective, it makes a lot of sense. You say, oh, I have a BPI character, and then we can do a handful of things, and those characters can jump, and they can drive, or they can do these things, and you implement them. But if one function has this one hard reference that goes and loads half the game because you ignored the rest of the rules for that one specific case, I guess, then you would load it for every single time you called any function from the interface. Because it is a beautiful tool if you do use it properly. So if you use the other techniques, like if you can return a character instead of returning your character, like the engine built-in character that doesn't have any hard references, then you can return that there, and you've now decreased a hard reference.
Using the higher ancestor class.
The higher ancestor class, logic-only classes, so that you can create that higher ancestor class if you need it. And if you use it in that way, and you look at the references for the interface itself, and if those are very little, now you can use it throughout your entire code without actually creating a hard reference to the class. So instead of saying, be my character, end jumping, that custom event that we added, you can create an interface function that says end jumping, and you could just say, call this interface function. If it implements it, then run it. Otherwise, do nothing. And you totally, remove the idea of making a hard reference to it, because you're only making a hard reference to the interface and not the actual class itself. Interfaces are also helpful for classes that don't have inheritance. And that's probably the main reason for it is, let's say we have a vehicle class, and there are two child functions of vehicle. There's a car and a motorcycle, or a bicycle, two-wheeler, and their versions of drive are completely different. And so you would implement you could have the drive function in the parent and then override them in the children as one way to implement inheritance. Another way is to use interfaces. It's like one of those, there's multiple tools to be able to solve the same problems. And interfaces is one of them for being able to have generic functions that either don't share an ancestor parent class, or, so my example was really bad in that case because they did share an ancestor class. Or in this case, to avoid using hard references is another really good use case. But what it comes down to is people then put hard references in it, and then it kind of defeats the whole point. So use them, but be careful. Tread carefully. Follow the other steps with them. You could try to keep to primitives, but eventually you're gonna have to return actor references too. You can cast outside of the interface call. Instead of having the type, you can say, I want to return an actor, and then in the result you could cast, but then you have casts everywhere. It could be kludgy. Anyways, we could talk more about interfaces if you've got further questions. So if you're in multiplayer, I got to give credit to Zach Burke. He's error 454 on the Discord server. He's not here today. I had this problem when I was doing multiplayer where my player controller class had references to everything, because the way you communicate from the client to the server is this thing called an RPC. It's just a message. But to do it, you must be the owner. The client must be the owner of that class. And only one client can be the owner of a specific actor in Unreal. And so I had this like, it was a potion station that anyone could use. And anyone could run up to it, start using the potion station and put ingredients in and make potions and things like that. And that had a widget, and they were pushing buttons on the widget, and that was sending messages to the server for the station to start brewing some potions. Well, what I did is I did this, where I would put all of my client to server logic in the player controller, because that's the default class that is owned by the player. And it wasn't just the potion station, it was also the arena bulletin board, and insert like 20 different things. And so I had to have all these different things, and it was all going to player controller, and that was having all these hard references everywhere. And then if I ever reference player controller, they now have to reference the potion station for whatever reason, right? Anyway, so what you can do is add a proxy actor, and so that what the idea of this, I'll just go through the workflow and maybe it'll make sense. So if your player is running up to like a merchant or a potion station or whatever it is, maybe it's a vehicle to get into the vehicle to start driving it, and the server says, oh, a player has entered this compounding box, and you can say, I'm going to spawn a proxy for this specific client. I'm only going to tell the client about it, and I'm going to set that client as the owner. No one else is going to know about this client, so you keep your networking pretty low, and then on the client it says, oh, I got this proxy just spawned for me, and I'm the owner. Great. So I'm going to spawn a widget to be able to then interact with it and purchase some goods, and then since I'm the owner of the proxy, I can now say, hey, I would like to purchase this good without even touching the player controller at all. And so now my hard reference is B merchant proxy has a hard reference to merchant, maybe the other way around, maybe both ways. And that's really it. Oh, and B merchant, the actual logic of what's the inventory in the store and things like that to be able to decrease and increase and things like that, and apply the inventory changes to the player. So this is a nice little cool little tip. I don't know if we covered all that. Yeah. I have an intro to multiplayer talk that covers RPCs and things like that. It is found on the Unreal PDX YouTube channel, and if you scroll up in the announcements far enough, you will find it. It might be pinned. And okay, and then a messaging bus. This is a cool one. So I use event dispatchers all the time. And if you're not familiar, event dispatcher is a thing in the blueprint. I don't have a picture for this, but we can talk more about it. It's a thing in a blueprint that says this thing has happened, this event has happened, and anyone's listening for when this event happens will be told about this event, and then they can process it however they want. It's a typical paradigm in programming called pub/sub, for publish and subscribe. And the problem with event dispatchers is you have to bind to them. So you have to say, hey merchant, I want to know when an item is purchased. Well, you have to say merchant, hard reference to the merchant right there. Bind to event, and then you can get it back. So now you have a hard reference to the merchant. When you just want to know that that a player's currency went down, or maybe not a great example to use a merchant, but you're going to create these hard references to every time you want to bind to an event. Well, you can use a messaging bus which anonymizes this thing, where you're saying, hey, message bus, I want to know when this thing happens. And the thing is defined by either like a gameplay tag, which is what I recommend, or maybe like a string, the name of it, which is operationally difficult. You can make typos. I don't recommend it. And so you say, hey, this gameplay tag, whenever it goes off, you're not creating a hard reference because that gameplay tag is like one of 20 things or 300, whatever your number of gameplay tags are defined in Unreal. It's an Unreal thing. We can talk more about that later. And when it happens, it's going to return a struct. And that struct can have variables in it with certain types. And maybe they do have a hard reference to some actor class, and that might be okay, because instead of like littering the entire message bus with creating those hard references, it's only when you have bound to that specific message of that type, you created the hard reference to that struct. And now you've decreased the chance of you cluttering your space for that. Unreal doesn't have something built in. They do have a plugin in the Lyra example called the Gameplay Message Router. That's the name of the folder under the plugins folder when you download it. Now in the editor plugins, it's called something else, like Game Message Subsystem. Why it's a misnomer, don't ask me. But there is a link at the end of the presentation that has a GitHub page that's not mine, which does a pretty good job about how to pull it out of the Lyra, download Lyra, pull it out, and how to use it. And all you really have to do is define a bunch of structs and gameplay tags, and you're up and running. And you can listen to anything anywhere in the game as I want this event whenever it happens. So this is great for like if you have day-night cycles and you want to know when dusk happens without creating a hard reference to your time manager that for some reason might have a reference to something it shouldn't, and now everything has references to it. So if you follow all of these tips, you end up having a really clean project. But the idea is you're going to mess up, and you're trying to just reduce the amount of references you have. And this is just another great tip that I've enjoyed. I've actually enjoyed the process of using a message bus more than the event dispatchers anyways.
So does that mean you actually just generate messages, which are packages that go onto the bus? You don't use dispatchers, and you're subscribed to the bus, not the object.
Correct. And so you create a hard reference to the bus, but it's a plugin, so yeah. And you create hard references to the structs, but yes. And so it is the true nature of a pub sub interface, public or publish subscribe, where it's I want to know when it happens. I don't care when or who it comes from. That could be part of your payload that you send is where it came from. So it's less useful if you've got like 1,000 of a certain type of actor and they're all publishing events because maybe you want to know for like a specific actor it happened. But even then, if you said for loop on an array of actors, subscribe to this event, you still have to pass who called that event in the event itself. You have to say publisher or something and pass the self-reference through. So regardless, it's the same kind of interface, I guess. So.
And it's fine that the struct you can update before the event occurs, so you can dynamically change the packaging of it so you can.
For sure.
So it's good for broadcasting out to a lot of people that are listening to it rather than a lot of people broadcasting it.
Correct. It's probably the most ideal way to do pub sub in all the cases. Now that I'm thinking about it, there might be one specific instance where event dispatcher is going to be more useful. The problem is it just doesn't come included, so you have to like extra plugin to be added, and it's not something that's maintained by Epic because they kind of just threw it in the Lyra template that gets updates. Someone's watching this video and they're not happy about it, but I've been using it and I haven't had to change it for a year now. I can pull up the link for that when we get to the end to show you kind of like what that the message bus looks like. When to use hard references, then the TLDR is whenever you need while being cautious about following the above tips. Because ultimately, you're going to need to make hard references, and you shouldn't be trying to ship a game. You have limited time, limited budget, move fast. Just one thing to consider is every time you make a hard reference, by remembering the things that make a hard reference, do you need to call functions on this class? If not, Do you really need to, can you use the is actor of this class? If you do need to call functions, you're going to need a hard reference because you have to call the function. But can it be put in an interface? Is adding an interface like too much time? Am I cluttering an interface that's like already too much cluttered? And you got to like judge that constantly. And I don't have the recipe for success yet, but should it be loaded asynchronously at runtime? Can it be a soft class reference or something along those lines? And can you refer to a parent class to do the same thing? Just questions in the form of the things that we've already talked about. And each time you'll decide later is another semi-permanent asset dependency, because decide later never happens. Okay, tools for reducing your asset dependency chains. So I will not cover this too much for the interest in time. We can talk more. These are the tools that I use. SizeMap is a great one. SizeMap, I don't have a picture of it right now. Okay, well, before we do that, right-click on an asset, and you can find Reference Viewer and SizeMap. And then from there, SizeMap is this picture that I showed earlier, where it shows you how many assets get loaded when you load this asset, roughly how big it is, and I blurred it out for anonymity. Wow, okay. Oh, yeah. Whew. I mean, that's where the money's at, right? So from here, it's kind of like a better graphic when you have less dependencies. In this case, it's kind of like hard to see things. But it can show you like, oh, I've got this one class and it's like much larger than I thought it was going to be. Oh, maybe I need to move this texture to like a child class or something like that. So this is a great thing for seeing how big a level is, or a sub-level that you're going to stream in later, or other kinds of things, but also how many assets are loaded. And you can see that UI player loads this thing on the top, which loads the thing in the bottom. It's like one thing that's contained in another. So it's a great way to look at a large amount of information all at once. And the reference viewer is this. I use the reference viewer a lot. And UE 5.0 and really 5.1 kind of like fixed all the bugs that went into 5.0 is so much better than the UE 4 reference viewer. I highly recommend it. But you can I still use it in UE 4. What the reference viewer is, it shows you all the types of references and the order. And you can say, hey, I want to search 20, I want to limit how many assets. If you got 5,000 references, it's going to take a long time for this thing to load. So you can limit the breadth limit, or you could uncheck that and then load them all. And then you'll see this like really large graph, which I can probably pull up an image. I just didn't include it. But by default, it shows hard references, which are the gray lines, and the magenta, pinkish fuchsia lines are soft references. And you can specify whether or not you want to see hard and soft references by going up to the eyeglass thing here. I think it's part of this menu in UE4. But in UE5, they moved it to this little menu, and you can say uncheck soft references if you only want to look at the hard references. But you can also look at the color of this. And you can also specify depth. So like right now, I'm only going one layer deep. I'm looking at my character. I don't know why I went 2 layers, but so you can see from my character, there's game state, and then things like that. And then going right is the dependency chain. So child, arrow to my character, child references my character, depends on stuff. So that's the direction of the reference. It does not show circular dependencies really well, but I have another tool for that. There is a plugin. I believe it's free. I will have to double check. I'm like 95% sure it's free on the marketplace. And this is a kind of a little widget editor utility thing for you to be able to find circular dependencies. In the traditional programming sense, circular dependencies are like a big no-no. You don't do them because You got to load one thing to load another thing that loads the thing that you're trying to load, and you just never load. Unreal has a nice smart way of being able to defer the circular dependency, but it can become problematic if it's too big, too long, or I don't know why, but in one specific case, the game crashed because of many circular dependencies, like 5,000 circular dependencies of length of like 300 chains. It's very, very bad. Anyways, that's a cool tool. It's okay. It's a great free tool if it is free. I'm pretty sure it's free. Check that one out. Then there's a hard reference finder. It's a free plugin. It's not on the marketplace, so you have to go download it from GitHub. This is a cool, let me open this guy. They both have this kind of feature. So the hard reference thing is I want to find my hard references in the specific class. And am I going to have to like load this 2 times? Okay, that's good enough. So it has this little widget utility in the editor, and you can see this makes 2 references to other packages. It's kind of like the reference viewer, but in the Blueprint utility itself, and you can double click on this and it will highlight the place where that hard reference is. Sometimes it's very hard, you're like, there's a hard reference to this class, but I have no idea where it is, and you can try using the find utility, but that only goes so far, so it's nice to be able to double click on the thing below and it will highlight exactly where the reference is. And the circular dependency tool does something similar, where if you click on like this button, it goes and scans all of your dependencies. It's a Blueprint utility, like most of the logic is in Blueprint, so I was able to like edit the Blueprint that came with it and say, I only want to scan this directory. It doesn't have an input field for it. It should, but it doesn't. So I could only scan like something, but it'll scan the entire the game, the whole entire project for circular dependencies. Can take a long time if you've got a lot of assets and a lot of circular dependencies. But if you click on the button, it will bring up that reference for that dependency. You can create custom C++ commandlets and use the asset registry to be able to like scan your own project and make custom tools and custom reports. I'm not going to cover that here. I would check out Mark's talk, and he covers it like just a little bit more, kind of more of an advanced way, but if you need to solve your problems, custom C++ tools are going to become necessary at some point. I've got these additional resources. There's a link to the slides that you can scan and get these links. Hard references and reasons to avoid them, that's from an article from Phil. His last name isn't anywhere. So I put at Wushu Studios. I got a lot of the content from there, so that's also a good one to kind of like do a refresher as a written kind of article. Asset dependency chains and the hidden danger is a talk from Unreal Fest 2022 from Mark. That's the one I've been referencing a bunch. It's a great talk. You can go and check that out. And guide on setting up the gameplay message router. That is the thing I was talking about, the messaging bus, which we'll open up in a second. And then you can always hit up Unreal Slackers for like a huge source of people that know how to do stuff, or the Unreal PDX community and get a couple of us that more of a tight-knit group. So before we go on to further, this is that message router. So I don't know if he pushed the source of the thing here, but you can get it from the Lyra example. And if we scroll down, it says go and get the Lyra game project here. Oh, I didn't know they pushed it to GitHub. You can download it from GitHub, or you can get it from the marketplace Lyra starter project or template, or something like that, and download that. And then go into the plugins project folder in that, and then get the gameplay message router, download that, and then if you're using it in C++, then you can follow these tools and things like that. they made a struct in C++, but you can make your struct in Blueprints. You don't have to use a C++ struct, where they just created these things. This is kind of like the payload of the message that's going to be sent. And here, let's just skip over this and go to the Blueprint stuff. And so part of the message subsystem, because the naming is hard for Epic, you do the broadcast message, and here they specify the channel is a gameplay tag. And you can specify, you can make new gameplay tags, I think, through this little editor. You can drop down and say new gameplay tag. You can also go to the project settings and add gameplay tags there. And so tags are kind of like hierarchical in the sense that player can have multiple tags underneath it, and player pawn can have multiple tags underneath it. So the player is, the pawn part of the player is possessing a thing. So we want to know an event when a player is possessed. The pawns for the player is possessed, probably. And they pass in the payload. This is a broadcast, and that's it. They, specify the values, and then later you can listen for gameplay messages, where you can specify that channel as well. You specify the payload type by selecting that struct, and then when on message received is called, you can get those details. That's it. And now you can use this one plugin to do events for your entire project. So I think it's a pretty useful tool. So there's this common thing around the internet programming. Broken gets fixed and shitty lasts forever. But I would like to add something. Or until your project decides it's time to break, and on release day, after you're already late, in a way that takes days, if not weeks, to fix. So, keep in mind that even though it doesn't feel like your project's broken, you might be setting yourself up for failure. But the project that I showed you, that's years of development. That's thousands and thousands of assets with several different programmers coming on and off the project with different mindsets. So, not every case is that bad, but if you take Mark's experience from a AAA programmer that works on Sea of Thieves and all these other cool games, they have problems too. And so, and their problems are also severe. You can scan this to get the access to these slides. And thank you. It'll be time for questions and answers. Anyone have any questions?
It feels like this is all in the realm of, as a wannabe programmer for decades, you're constantly aware of inherent child. And so you give a talk on multiplayer, or this talk here, it's an awareness thing. So questions don't really come.
Questions come when you're in the weeds and the problems came up, right? Yeah, for sure. It is definitely like an awareness thing, and it's one of those things that people don't even. That project, the person told me, I didn't know casts make hard references. I thought that that's okay. It's just people don't know because it's not part of the educational pipeline of learning Unreal. Is learning this part because it's the publishing the game, it's the putting it out to market, it's these things that are learned over time, usually through the hard way. And yeah. Question? Is the ancestor chain a common term? I don't think ancestor chain is, but asset dependency chain is used by Mark. I don't know if it's a really common term.
I love the term ancestor chain.
Yeah.
Any other questions?
I noticed that you have buttons for loading assets, how about unloading assets?
Yes, I can't, you can. I think that if you have a object reference, the darker teal, I don't think you can control when it gets unloaded, but that soft object reference that we were talking about can be unloaded. Just like how there's a loaded into memory, there is an unload. Otherwise, you're up to garbage collection to unload it, and that happens when it happens.
When you use the destroy actor node, does that unload it, or is it just deleted from player's interaction?
Yeah, so does the destroy actor unload it, or does it just delete it from the player's interaction? Great question. Destroy actor queues it up for garbage collection. It immediately just removes it from the player's HUD and things like that, but it doesn't get destroyed immediately. It kind of says, I'm pending kill, and the garbage collection comes every so often and says if it's pending kill, it'll then delete it from RAM. And then it'll say, okay, for each things that were loaded because of that actor, can we unload the whole class? Can we unload these different things? And it will try to smartly detect when to load and unload things. But usually, it tries to keep things loaded more often than not. Because you're trying to have like a more smooth experience, and so unless you're using the tools to load and unload stuff manually, it won't load everything at once. But if you unload a level, if you load a different level, that other level does get unloaded, but by a garbage collection at some point in the future. You can, I think there are C++ endpoints functions for you to tell the garbage collection to run, like explicitly, if you need to, like, hey, I'm loading this level and I had like 3 gigabytes loaded in this last level, and like we really need to like cut down now before I load this next level, so let's go into an intermediary loading screen level so I can force garbage collection to do it, because your platform requirements are telling you, like, look, you only get so much gigabytes of RAM. Don't think there's a tool for that in Blueprints. You can expose it, but you got to know C++ to do it. Any other questions?
Yes.
Yeah.
When you said soft object references are still hard references, I don't understand that, because you said they do still, they're not loaded immediately when the asset's loaded, so how is that still a hard reference? What does hard mean in that context?
Great question. So the question is, I said soft object references are still hard references, but they're not loaded immediately. So if we have this B actor is my class, or here, and we say soft object reference, I'm creating a hard reference to B actor, okay? To the class B actor by doing this. So everything in B actor does get loaded. The class gets loaded. But the value of this variable, which is we can specify some instance of B actor, say a child class inherits from B actor, and I want to say the default value of B actor is B big boss that's got a bunch of stuff on it that inherits from actor, but I don't want to load boss yet. I will load B actor, but I won't load the boss, even though the boss is set as the value in the default. In the details panel under default, the boss won't get loaded. So the values themselves don't get loaded, but the class that you are specifying does. So it would
load all the hard references that
B actor, yeah, it would load all the hard.
It just won't load its class default textures, etc.
It will load everything that's in B actor as a hard reference. So if B actor has textures and all those things, that will get loaded. Let me.
But not if it's in the defaults page.
It might. Yes. I'll try to start up Unreal so maybe I can show you like a real example. But specifically, B actor gets loaded. But if you have like a child class of B actor that you want to use for the value of that variable, that actor won't get loaded, whereas normally it would. It would create a hard reference.
I think a good way to think of this is, you see in the UI where it says soft think of that as telling you which part of it is soft. So soft class reference, the entire class is soft as it not loaded. But soft object reference,
That was a good way to.
the class is still hard, but only the object instance of that class is soft. So like instance as in like, if you have the class be actor, that's like the blueprint you define in your content browser. And then when you place an instance of it in the world, that's the object. That's the part that doesn't get loaded, which is a soft object reference. Until you tell it to load.
Correct. So for the recording's sake, Nick just said that the soft class, the class itself is not being loaded. Right? And for soft object, the value of the it's not intuitive because the soft object reference has a class. The class is hard, but the object, the value of the variable is soft. Correct. And then even though soft class references both have the class of the soft class and a value that you can set it to, like a child. Can you? We're about to find out. Yeah, we'll find out. It's confusing. So while Epic's Games Launcher decides to let me load the engine, any other questions?
So does I don't really use the profiler tool, but it looks cool. Would this help you determine perhaps that your hard references are the source of your?
So the question is, does the profiler tool help you with determining hard references and things like this? My follow-up question would be, which profiler tool? There's Unreal Insights, there's the session front end, and one could say that SizeMap is a profiling tool, but that's a stretch. But you're probably thinking of Insights, but Session Front End also has colorful graphs too, but they're phasing that one out. I believe the answer is no. I don't think it's there. Yeah, I think the answer is no. It's not meant for that kind of profiling. It's more for CPU usage, GPU usage, network usage, RAM usage, but less about class hierarchical and when things are getting loaded or not loaded. You can see the profiler that wow, it took a lot of time for this one frame to load because we were loading this asset, and that might be the first note that something's wrong that you now need to go look into this specific asset when it got loaded. So yes, it's a good first thing of my player is telling me the game's is taking a really long time to load, and then from there you can drill down and oh, it's trying to load this asset, and that took a really long time. Now you use the other tools to drill down further. Okay, so. Hard references are going, the thing that hard reference, the device that hard references affect are going to be both CPU and your disk. So because you have this hard reference, you're spending actual CPU time to load it. That's the processing of reading from disk, so you're waiting for disk to tell you, here's the asset, and then you're loading that into RAM, and that's going to, all of that kind of is this atomic transfer of thing from disk to RAM. And the CPU it's not going to be super heavy for the CPU. You're going to be disk bound more than anything else. Okay, so we have we're in B-bomb right now. This is a class that we're going to make we want to load B child in it at some point in time. So we're going to make this variable called the child, coincidental. And we're going to change this type to not B child because we don't want to load B child. We just want the logic in B parent because from a logic perspective, that's all we need from BOM. Because we're going to run functions in BOM to do stuff for the child, but we'll type in parent instead of child here, and we'll create a soft object reference. And then we're going to compile it. And then over in the details panel for the child, we're going to specify an instance of it that we don't have. Okay. So I don't use this very often, but we're gonna work with what we've got here. It's wanting like a real live thing that's like instantiated. So we're gonna just drag bChild in here. Now, the level has a hard reference to bChild. It's gonna load bChild. This is so confusing.
This might be one of those know that it exists and then go research it when you need to visit type of things.
Yeah. So like, oh, but I don't want B. There's a talk called Understanding Soft Object References Inside Unreal, and Christian Allen does like an hour-and-a-half video. You can skip the first half hour, and he covers the use cases, and I just didn't look into it too much further. I'm sorry. I'm guessing it is not meant for actors, but maybe for like, he used it for like skeletal mesh components and loading a skeletal mesh. So yeah, sorry. Maybe that's because we're using it as a variable and not as a. So if we created a blueprint and its actor component, AC parent, and then we say add AC component, or AC parent, and parent had some material, and we change this to a material soft object reference. Okay, so we can pick a material now. So I created a material in bparent of type soft object reference. So it's maybe not useful for actors, but for assets specifically. And so we could create our own material, M expensive, and get this to go away. And now material, it has a hard reference to the class material, but it doesn't have a hard reference to M expensive. And M expensive gets loaded dynamically whenever you tell it to load, which you can do some material load, async load asset on, we could say like delay. So it'll load it in a quarter second later after the B parent loads. So material has a hard reference to material, and I can show you that. And it has a soft reference to M expensive. So if we go to here to B parent, and we go to the reference viewer, I don't know why it has a soft reference to none. That's odd. Oh, so I don't know why it's probably not showing you a hard reference to material because it's a C++ class, but you can see here now we have a soft reference to M expensive because M expensive is still a reference, but it will get loaded later. But if material was like, material is a really bad example because child classes don't really exist. They're like material instances, but this selection right here is a hard reference. But this is a soft reference. Does that help explain it a little bit better?
Something's in there.
Okay.
It's a hard reference to a soft reference, which is a deferrable load.
Right. The hard reference is to the type of the material, the type of the variable, and the soft reference is the value of that variable that you set in the details panel. So, like another way to do it would be if we created, so they said a skeletal mesh. Can we create one of those without all the fancy stuff? I think we need like an actual skeleton to do that. Anyways, that's the intro. Go watch Christian Allen's From the Inside Real to really understand it more. But generally, that's the principle, is the variable type itself is still a hard reference, but the value of the variable is a soft reference. Okay. Any other questions? Cool. Well, thanks for coming. I really appreciate it. And hit us up on Unreal PDX if you've got any more questions. And I think we'll go and head over to 10 Barrel Brewing now to get some drinks and food.